Depending on where you are in the world, good morning and good afternoon. Thank you for joining us today for our Operational Impact of Cloud and Virtualization webinar, the second session of Ribbon and ECI's Communications Insights for Utilities and Energy Industries webinar series. I'm John Ryan from the Ribbon and ECI channel marketing team, and we're pleased to have a global audience joining our webinar today. Before we begin, please note that you can submit a question to our team using the question and answer window on your screen. We will have time near the end of the webinar to review the questions submitted. Additionally, please note that within 48 hours, you will receive an email with the webinar recording, along with our newest white paper on distributed network intelligence in the age of distributed energy resources. If you'd like an early look at the white paper, you can find it right now on the handout section of your screen. And with that, I'll send things over to Simon Beard from the Ribbon and ECI Global Channel and Program Development Team, who will moderate the webinar. Hello, Simon.
Hi, John, and thank you very much for your introduction, and welcome again to everybody who's taken the time to join us today on this session, the second session in our Communication Insights series. As John said, we're going to be taking questions all the way through the webinar in the questions window. And then at the end, we will pause and we'll go through your questions. We'll try to get everybody's question answered as far as we can. We may have to get back to you if it's a particularly difficult technical problem to answer, or if it's going to take us just too much time to get through all the questions, but hopefully we can avoid that at the end. We have two speakers today on the topic of operational impact of cloud and virtualization. David Stokes from our portfolio marketing team, and Marco Berger, who heads our critical infrastructure solutions team. And without further ado, I'd like to ask David to kick off the presentation for us. Over to you, David.
Thank you very much, Simon, and thank you everybody for joining. As Simon mentioned, we're talking to you today about the impact of cloud and virtualization on mission critical businesses in the energy and utilities sector. So if we move on to slide 2, there is much cloud and virtualization functionality now in the network, field proven and deployed in the service provider land. This is now in the process of being repurposed and hardened for use in mission critical applications. However, as ever, there is fear that this new technology will either take jobs, require reskilling and training, or is not appropriate in some way for the mission critical business and the way they operate, or maybe it's just not secure enough for mission critical OT environment. The aim of this webinar is to show you that these new capabilities, once they have been hardened, taken from the service provider world and hardened and made appropriate to the mission critical business world, these new capabilities provide operators of mission critical networks with more accurate real-time data, and this then allows them to make more informed decisions based on accurate real-time data, as we mentioned. We will also show that the tools are either intuitive to use or indeed automated, so learning to use them is a matter of practice rather than reskilling. And then we will discuss why these capabilities are not only appropriate, but they are essential to address the challenges and opportunities facing mission critical industries today. And finally, we will show how these new cloud and virtualization technologies offer the opportunity to be more secure than the existing legacy technologies. In the past, we thought that legacy technologies like SDH, SONET, TDM were secure, but these technologies were not built with security in mind. And it is not surprising that it turns out that it is not difficult to introduce malware across them and through them. Whereas this new technology of the cloud and virtualization technology has been architected with security at their hearts. And hence it's far easier to build, adapt and evolve security mechanisms with these new modern technologies and techniques. So in fact, it turns out that modern techniques help you in securing your mission critical OT networks. So let's start by looking at the change in business needs that are driving the need to adopt these new advanced technologies. Firstly, all mission critical industries are looking to become smart. This requires a vast number of IoT and industrial IoT devices to be deployed in the network. These devices allow the network to be monitored and controlled in far more detail than previously that we had, and allow operations to react to changes in the network in real time. So, for example, modern phaser measurement units, PMUs, now send data 30 to 60 times per second. And even SCADA sensors are generating data every 2 to 4 seconds. With this vast amount of information, automation becomes key. It's impossible to handle all of this data and process it visually by an end user. You need automation systems to really collate this data together to generate information, which can then be acted upon either autonomously or by overall control by the operating staff. So that means control systems are introduced that provide this autonomous operation on the minute-to-minute operation of the network, allowing the operators to focus their decision making on exceptions and improving the quality of the way the network works. The devices used to monitor and control the network are increasingly becoming virtualized. And several vendors are now offering, for example, virtualized SCADA packages. The advantage of these virtualized packages is that they support all protocols. So for SCADA, Modbus, DMP3, Profibus, etc., etc., etc. And they are also decoupled from the hardware. And they can then be deployed on standard off-the-shelf hardware. So whilst the initial investment for these virtualized systems may be higher, the TCO rapidly becomes cheaper as the functionality is no longer tied to a specific hardware or to a specific vendor. In addition to all the data generated from the IoT and IIoT devices, we are seeing a massive increase in the amount of the video being used by mission critical businesses. So HD video is being used to provide infrastructure surveillance and the access control required to access secure sites. Also, there's of course a need to provide broadband connectivity to workforces which in the oil, gas and water industry can be located on very, very remote sites, and these guys need access to broadband these days. So massive increase in video for surveillance, either site security or monitoring distribution networks over their geographical reach, or and providing the broadband to the network users. And we should not forget 5G. This will have a huge impact. First, it provides, as we all know, or is meant to provide, a ubiquitous platform for connecting devices. You know, the mass machine type communications part of 5G is perfect for picking up the connectivity from the IoT and IIoT devices in the field area network. And indeed, having that sort of ubiquitous communications will allow more devices to be put into the network because you can connect to them more easily. But as important as 5G is as a connection technology, the technology used to transport 5G is also key in the mission critical business area. And so the sort of technology being developed to support 5G, technologies like segment routing, flexible Ethernet, network slicing, are all very, very relevant to the mission critical business area. And these technologies are introduced to provide deterministic transport, so you can guarantee what the latency is across the network. And with network slicing, you're able to configure the isolation between different services and applications. So in effect, segregating your network. And that becomes increasingly important as we move to a converged IT and OT type network, which we will see on page slide 3. So what we should point out before moving further in this on this slide is you're talking about introducing cloud into the IT and OT environments, and we should point out that the public cloud that might be used for the IT network is fundamentally different from a private cloud you'd be deploying for the OT network. Cloud does not mean it has to be open. So whilst in the IT cloud, you can gain the benefits from being able to use industrial leading public clouds from Microsoft, etc. This is absolutely not the case for the OT network. The OT must use a private cloud. And rather than thinking of this and comparing it to a public cloud like AWS or Azure, it's more accurate to think of this as being your existing control center, but instead of being centralized, this control center is now distributed across your network. And this distributed control or private cloud is only accessible to you, has all of the security you employ in your centralized control center, and is able to do the compute type functions where and when they're required. So why would you want to distribute your OT control? Well, you need to do this to address the challenges identified on the previous slide. Much of the data being generated by IoT is time sensitive and needs to be analyzed in real time. This means we need extremely low latency, and it makes sense to do this with compute located closer to the devices rather than hauling that data all the way back to a centralized core. The same applies to surveillance information. You want to make decisions locally, and then, if necessary, send the derived knowledge back to the core. And this has multiple advantages. One, decisions are made in real time, and hence you can deal with time-sensitive applications. Two, the amount of data backhauled to the centralized compute is greatly reduced. And three, security is improved, as not all the data will be accessible on those long geographical reaches as you're trying to backhaul that data to a central core. You process it locally, deal with it locally, you can secure it locally as well. So hence, much less vulnerable to man-in-the-middle type attacks. And as we mentioned at the start, distributed compute started with service providers, and we now see it moving into the OT. And as I mentioned previously, a number of vendors are offering these virtualized SCADA platforms. At the same time, we're seeing an increasing number of access points between the IT and OT networks, and we see many processes no longer being limited to just the IT domain or the OT domain. And we start to see many cross-domain applications, for example, metering, demand response systems, asset management, maintenance, etc. These need to run between the domains with increased levels of security to protect the OT domain from attacks initiated from the IT domain. So in the IT world, we can use the best public cloud systems on the market without having concerns about the overall security of the OT network because they are strictly separated and segmented. And in the OT domains, to make proper use of the data that is being generated in this domain, we must be able to store, manage, and analyze the data locally. This allows it to be done in real time, as I say, gives you all the access to those time-sensitive applications, with your ability to handle all the bandwidth and low latency networks. To further improve it, we start to see further we start to see further pressures or desires within our energy and utility customers to start putting optical networks in this OT type networks. Firstly, optics absolutely well suited to high bandwidth applications. It's very acknowledged that optical DWDM networks offer you the lowest cost per bit for transport, but also they offer you the lowest latency. And thirdly, they're very easy to encrypt, so add good security across your network. So we see optical networks playing an increasingly important role in this OT cloud. Then once we've got this OT infrastructure in place, we have to start with the premise that it is vulnerable and it will be attacked. This means that we have to put a lot of cybersecurity solutions across all the layers of the network to ensure that processes and the operational data is kept in the closed domain of the OT network. So when we talk about IT-OT convergence, the starting point always has to be utilization of the same technologies for both domains. But this does not mean running on the same network elements. At this point, I don't believe we have the segregation to allow that to give you the security that you want. But by using the same technologies, this allows you to simplify the supply chain and allows, for those reasons, the CapEx and OpEx to be produced. And as technology advances, we'll be able to consider running the IT and OT on the same networks. And then coming back to these technologies that 5G is introducing, with 5G, we are starting to see extremely effective slicing technologies that allow the network to be segregated, such that one slice across the network can be completely isolated from another slice across the network. This means slices and applications that run over one platform can be strictly separated between each other. And in addition, each slice can be configured to give completely different performance characteristics, i.e. one slice can be designed to be extremely low latency, whereas another could be designed to be, for say, an IT network, provide dynamic VPNs. So basically the network can be set cloud in place. You have all of that information from the industrial IoT. You have local compute and intelligence systems data into knowledge and action that really allows you to make your network smart. And you start to see the introduction of this term AIoT. So if we move on to slide 4, we'll just focus on some of the advantages. So firstly, it's about understanding, start moving in this direction. It's about understanding that cloud, in this case, but also virtualization, as Marco will explain, really allows you to address many of your concerns and challenges that you have today. So for example, you've got widely geographically dispersed networks. Cloud allows you to provide processing power where it is required, and this allows you to minimize latency and meet the needs of those time-sensitive applications. With localized storage, you're storing data close to where it's going to be used, which makes much more sense if you need to re-access that data. And it makes a lot more economic sense rather than pumping all that data back through the network. And these edge compute devices can be designed to be highly available. For example, RAID 6 devices are and have been designed to be 6 nines available. But should a device fail or the connectivity to the device fail, as you've got multiple of these edge compute devices, you can just fall back to the next compute device in the line. So you also have this additional availability in your network that you can, if anything happens, you can move the compute resource from one place to another. You're not reliant on a connectivity all the way back or to a central core. Much more flexible availability. So highly available edge compute devices and flexible reliability across it. And of course, you get a migration from CapEx to OpEx. In IT, that's pretty obvious why that happens. You're moving from bespoke hardware through to software-based systems. So you're moving from buy a product, deploy it in your network, and then if you need to upgrade it, you have to buy additional cards, etc. And that's obviously a CapEx model. As you move to the cloud in the IT network, you're moving to basically software and you're paying license fees on the software. In the private cloud, it's slightly different. In the private cloud, you're deploying these virtualized OT applications like the SCADA virtualized servers. So very similar to that. The hardware is just off-the-shelf hardware, and you're deploying these software applications upon those, and you start to not get vendor tie-in. You're able to evolve that network very rapidly, but in doing that, you're paying a license fee. So the cost of the hardware isn't your limiting factor now. You're moving into a yearly license fee to be able to use those applications, so CapEx to OpEx. And then the whole of this localized compute really does unlock the big data analytics that allows you to move to a truly smart network. So firstly, what does that mean? In the maintenance world, virtual reality and augmented reality is real. It's being used now in railway networks, for example, well beyond the pilot phase. And in distribution networks as well, because they have wireless networks in place, we see augmented reality being used to allow less skilled maintenance staff to go out and maintain the network, because they're getting real-time and online information and visual aids from the AI server or an expert in the control center. So you can really start to send people out and provide them all the information they need to move forward with their network. These big data analytics helps you improve your customer experience with intelligent management of resources. For example, smart metering allows you to get precise billing information hour to hour, minute to minute, which allows the end user to really understand what is expensive in their houses and their premises and start modifying behaviors. Really important first step in this experience type approach. And we'll see that being taken further and further and further. The efficiency of your network can be massively increased. For example, energy networks is not uncommon to lose 20 to 30% of the energy that's produced. This is either due to bad prediction or non-utilization of the supply that's been generated. And this is caused by not correlating production from the distributed energy resources with production from the main power plants. And this is because the grid is just not smart enough at the moment and can't respond quickly enough. As you deploy the smart networks with the data analytics, you're able to react very quickly so you can match the generation to demand. Then finally, as I mentioned slightly earlier, the smart analytics you can get from the CCTV gives you the ability to give really secure access control to, for example, your substations and to protect your distribution networks. So that was a brief run through on the cloud side. Marco will now talk to you about how things are moving forward on the virtualization front and how they're applicable to you.
Thank you, David, and good morning, good afternoon to everybody. So let's talk about virtualization. Virtualization is about to create, run, deploy, install different services using a shared platform. And of course, this means it goes ahead with several names that we are utilizing in this presentation. Virtualization goes along with the cloud systems or private cloud systems. It goes along with edge computing capabilities, and it goes along with the network functionality virtualization. So it's a lot of new terms and specifications which are quite new to this marketplace, to the critical infrastructure marketplace. But as time passes, as David commented before, people will get acquainted with these new technologies, with how they can implement and how they can operate it. It's very simple, quite effective, and some extremely useful use cases are being addressed by virtualization. For example, we can run real-time worksite safety and security tracking using smart analytics, as previously said by David. We can improve productivity through a much better monitor of, for example, in the energy market, the energy quality through the readings of the different PMUs, phasor meter units throughout the network. We can provide a much better asset management to passive, active assets that are present in our network. We can concentrate data and information coming from the millions or tens of thousands of smart meters deployed in a field area network, in business and residentials. We can provide control for automation systems, okay? It can be automation systems deployed in a production plant, but can be automation systems related to the operation and security of pipelines and power utilities as well. And we can virtualize SCADA and HMI applications sharing the same platform. And this is nothing new, okay? This is something that key vendors are already providing or introducing into the market, and we are looking at private cloud and virtualization tools coming from General Electric, Schneider, Siemens, ABB, Indra, Mainsight, and many others. And just a reminder that Ribbon ECI was one of the first to deploy NFV technology to provide a holistic or a multi-layer cybersecurity solution for our customers. It was back approximately 4 or 5 years ago. And we will talk about cybersecurity strategy, systems, history, and then functionalities in more details in our presentation next week. So please stay with us till next week. But in order for this virtualization platform to be relevant for the critical infrastructure market, several challenges must be met. First of all, availability. We are used to have 99.999% of availability. We must have a reliable system installed and in place. We have to have protection and redundancy schemes and mechanisms in place. And of course, this must be a very secured platform. But on the other hand, we have many benefits. We have one, the isolation, since it is a system or a platform that is installed in the already segmented, separated OT domain. Okay, this is not something that goes to the public domain with the external interfaces to internet. No, it's within the protected and segmented OT domain that we are used to. We have hardware independence, meaning we can achieve a better hardware independence. So our supply chain is improved. We can purchase equipments and capabilities with more easy, and we can partition all the resources that we have in the different data centers for different applications and apply, as David commented early on, a centralized security policy as well as a disaster recovery mechanism. So data is not lost, storage is kept, and all the processes continues running 7/24. And that's the main point about OT networks or processes. We must be capable of running and supervising and operating processes on a 7/24 scale, and this is very important. So in the next slides, we will look at how a virtualization platform looks like into the context of critical infrastructure. So in one hand, we had a library of different applications and functionalities. Okay, this is virtual network functionalities. It's a library of different software systems, and we start with some typical software systems and applications that are typical encountered in the IT environment. Okay, one optimization, distributed denial of service, voice over IP, storage, edge routing, okay, that can be deployed easily on different sites. And on top of that, since it's a very dynamic platform and we can enable deployment and operation of a variety of different applications, we have developed for this ecosystem OT IT dedicated security catalog of appliances and services. So we are talking about a variety of cybersecurity functionalities that are focusing on the OT network with their specific and special requirement. And we will talk about that, as I told you before, in our next presentation next week. So we have advanced firewalls from different vendors. We have SCADA anomaly detection systems from Clarity and other vendors. We have encryption on many layers and from different vendors and in different flavors. It can be software-based, hardware-based, etc. And with the DDoS protection that we previously utilized in the IT environment can also be utilized in the OT environment as well. So this is a very, very flexible platform, and it maintains a very high level of security and safety, okay? So how it looks. First of all, we have a number of elements, and I will describe those elements in more details in the next slide. So first of all, we have the Muse Orchestration System. This is a software package that is installed in the Security Operations Center or in the Network Operational Center. It has at least two main interfaces. One is the dashboard through which we manage, deploy, install, and operate the different functionalities. We have a catalog of VNFs, of virtual network functionalities. Okay, this catalog can be augmented or improved as time passes, acquiring new or different licenses. We have, of course, the OT network and the connectivity to all the remote stations that are part of our network. And in each one of those stations that we want, of course, to deploy those flexible package of services, we can have two different flavors. We can have, if it's a ribbon ECI network with Neptune network elements, we can have a NPT blade. Okay, it's a card, a module that is inserted in our modular devices, and it provides the required white box functionality. Basically it's a x86 server, okay, that is installed and operated within our communications platform. And if it's not a ribbon ECI network, it's provided by any other vendor, we can install and deploy standalone boxes, okay? Commercial off-the-shelf system. And on top of those devices, install the different virtualized applications. It can be encryption, it can be a secure gateway with firewall, escape anomaly detection. It can be any one of those different packages that we saw previous in this slide, okay? Any one of them. So let's look at them with a bit more details. For one side, we have the best of class services packaged in virtual network functionalities. So for OT applications, we have anomaly detection, firewall, encryption, DDoS protection, but we have many other applications of functionalities available. And this is a catalog that increases as the market and the major vendors make available new functionalities. Okay, this is something completely flexible, and it does not force us to change our hardware. So the platform stays in place, and what is changed and upgraded and operated in different instances are the different VNFs. In the central side, we have the orchestration and automation tool, the Muse, okay, which provide a full service lifecycle management, provides the automatic configuration and zero-touch provisioning for those different VNFs available in our catalog. If we have applications that provide services to external customers, for example, if we are a utelco, carrier of carrier, we can add advanced customer management on top of the services that we can analyze and monitor using the Muse. We can customize it to the end user, and it's a very scalable and high available system, of course. Here we have an uncompromised security all along the different elements of the system. Okay, we have tools for provide access control, to provide security for the different VNFs, NFIs. We have a secure boot and runtime. We have hardware-based authentication, which is very difficult to break. And of course, we have several tools to deploy systems with high availability as well. In the remote sites, okay, and distributed alongside the network, we have the different Mercury Shield elements. Okay, Mercury Shield is the marketing name in our case, but it's a white box. Okay, it's a commercial off-the-shelf system, and it can be a separated hardware, or, as I told you before, a blade in the Ribbon ECI Neptune platform. And this white box, we run our NFI operational system, and it interworks with the orchestration software that we have installed in the SOC or the NOC, and we can have multiple wide area network and LAN interfaces and zero-touch management. So once it's installed and deployed, we have the workload in this platform is very, very, very low. So it's a huge improvement to what we had before. So let's look at what in a utopic world, future electrical substation would look like. Okay, so let's imagine that we have the OT network. We have a Neptune network element providing the communications of all that we have in this specific substation through the operational network and the network operational center, of course. And we have in this substation all the different RTUs and the intelligent electronic devices, the IADs, and all the alarms and sensors connected using Ethernet media, okay, an Ethernet ring or many Ethernet rings using high capacity and very fast protection protocols in place, HSR and PRP, which will be the typical substation ecosystem in a few years from now, okay? And let's imagine that in this specific substation, we would like to have a voice over IP system to replace, to improve the legacy PABX that we had previously with the old generation voice and unified communication systems. So this voice over IP system could be deployed virtually using the NFV card available in this site. Okay, in this case, it's a blade inserted in the Neptune network element. Okay, so let's go one step further. Let's say that we would like to better monitor and supervise our SCADA systems, to add a SCADA gateway. And why it would be necessary? Because maybe we will have such a huge number of devices being monitored and supervised that the amount of data being relayed to the network operational center is huge, and we would like to diminish this data and to send only the most critical information towards the network operational center. So we provide a gateway facility for that purpose. The same for IoT. Okay, if in this specific substation we have hundreds of IoT sensors providing control and supervision of windows, doors, air conditioning, and many other different applications within the substation, we can provide a gateway to provide local and communications between the devices and a gateway to the outside world, a firewall. Today, in most of the power utilities, oil, gas pipelines, there is an increased need to have a firewall deployed in every single remote station. And this firewall is necessary to overcome some specific threats that have been recently deployed or seen in this marketplace. So one of the possible threats, is what we call lateral movement. So if a malware affects a nearby substation or one of the substations, and it tries to propagate from one site to another, this firewall will provide a first level of defense for this specific substation against this case. And another case is a malware coming from the IT through the OT network and trying to penetrate the very mission critical environment that we have in this remote site. So firewall is always good to have in place, but not enough. Let's say that we need to provide connectivity for a local workstation, for a technician, for an engineer, and a local printer. Okay, so they have all the administrative tools and information at hand. So we would need a local router. So all those different functionalities, they won't be hardware based. They will be software based and will be able to be deployed using this NFV platform, including CCTV systems. Okay, for example, if we have a CCTV system without a local storage capacity, which is very common because those are local storage is quite expensive. So we will be able to install the storage on the cloud or a public cloud storage software that will streamline and compress all the video streaming from those CCTV systems towards centralized storage systems installed in one of the data centers in this critical infrastructure entity. So we are talking about a system that provides or improves the visibility and control over the entire network. It provides a central system to manage and orchestrate the different functionalities. It provides us more flexibility, so we can add VNFs from different vendors as we want and as we need. It has different tools for zero-touch provisioning and deployment, so it's very easy to operate. And of course, we take advantage of a very comprehensive and large catalog of services. So this is a very important tool that I believe will be part of the ecosystem in the critical infrastructure OT network in the future. And this is not science fiction, okay? If we look into the market today, and as I told you before, Ribbon ECI was one of the pioneers by developing NFV-based platform to deploy advanced cybersecurity functionalities for OT networks. But you can look at this press release from several months ago. Okay, this is not one only. We have several of those press releases, and this describes what Deutsche Telekom is doing using the same technology and platform that I just described. Okay, they are deploying a system, a platform over a variety of sizes and designs. Okay, pole mount, ruggedized, standard rack. Those are the white boxes that I mentioned before. They are running real-time control of machines. Okay, and on top of that, edge analytics. So this is a system that is capable of delivering control in a latency-sensitive environment, and in parallel, analytics to improve productivity and efficiency for the customer. So this is a commercial product available today as we speak. So that was my part for today, and Simon, if you'd like to help us with the Q&A part, we are fully available to answer any question that you may have. And meanwhile, thank you very much. Simon?
Yes, thank you very much indeed, Marco. I hope that has given you all something to think about today in terms of what is fast becoming a reality and an option for the utilities critical infrastructure business. So I'm just looking down at the questions here that we have. I have one question. I think this is probably one for Marco. The question is that on chart 6, there is a number of VNFs in a library. Can these all be deployed in a substation with your solution, and what are the limitations?
Okay, this is one of the marvels of NFV technology, because we are, through the utilization of NFV platform, we are capable of deploying and operating multiple VNFs simultaneous. But the precise number will depend on each and one of the white boxes that we have purchased in the first step. It depends on processing capacity, RAM, storage, and this differs from appliance to appliance, standalone, non-standalone. Each white box that is installed in the remote side has different capacities, and these capacities will provide us the guidelines of how many VNFs we will be able to run effectively in each one of the sites.
Okay, thank you very much, Marco. I hope that's answered that question. I have another question relating to the VNFs. Are you able to add a customer's preferred VNF? So maybe not, I guess that means not one from one of our libraries, to your NFVI, and how long does the integration typically take for a new application?
Okay, it's a very good question, and as I told you before, this is one of the goodies that allows us to create independence from different vendors. So if there is a new VNF in the market, or new functionality that is, of course, capable of being transformed or packaged into a virtual software package compatible to the NFV platform, the time to integrate in our catalog, okay, in the Muse orchestration system that we have, is today, and looking at the current R&D resources that we have today, it's a maximum of 3 times, which means a regular new product release timetable. So from 2 to 3 months, this is the average time that you take us today to have completely new functionality and to deploy, to test and deploy in the over the NFV platform of any customer.
Okay, thank you very much. Okay, I have a question here which relates to the NPT blade. You've referred to the, I guess, the blade that goes into our equipment. So we're showing the deployment of the NPT blade to support cybersecurity applications. Why do we need this sort of application at the substation? What kind of attacks are we trying to counter with this?
Okay, good question, and we will see. We will have a very detailed presentation next week covering OT cybersecurity. But in a nutshell and very fast, we can say that we are trying to deal with 3 major threat scenarios that we have analyzed and make on our top priority. So one of them is the man in the middle. So we're talking about people trying to tap, to intercept data, to let's say to damage the integrity of data in the media, in the fiber optic infrastructure, or in the microwave infrastructure. So this is one threat scenario. The other are, as I spoke before, threats that are coming from the IT and trying to penetrate the OT and the lateral movements, okay? And last but not least are the threats that are installed and deployed within the secure substation or site fences, which is a much more difficult to deal with threat. And for that, which is a threat that affects the SCADA, the relays, the telemetry, all the mission critical systems running in that specific site or other wells. So those 3 scenarios we are trying to address.
Okay, thank you very much. So I have a couple more questions. So this one is a little bit more technical. We talk about the ECI NFVI OS interworking with the Muse orchestrator. Are both the NFVI OS and the orchestrator your proprietary products, or do you use OpenStack, for instance?
Okay, well, we have an expert, and that's good. So basically, our strategy is to promote the NFV for utilities to be deployed and operated within the secure boundaries of the OT network, and to keep it as a platform as much as possible, an open system, to increase flexibility and lower the TCO, the total cost of ownership. So despite that we are running into a very closed environment, the system itself is based on a lot of open source softwares. And in order to keep the whole portfolio, the whole offering secure, in Ribbon ECI we have implemented since back a long time what is called the SSDLC, the Secure Software Development Lifecycle Procedures and Policies. So we look at the security of all the products, hardware and software in Ribbon ECI from the early stages of product definition through R&D, different R&D stages, through VNV, deployment, and operation. So of course, we try to be as holistic as possible, but our main objective here is to provide a secure platform, even though that we are using open source systems. Yes.
Thank you. Okay. I think I have time for maybe one more question. So this relates to the final chart. I think it says you indicate that the Edge Air offer from T-Systems is available in pole mount, ruggedized, and standard rack configurations. Are all these configurations supported by your solution, and what configurations are deployed in remote OT locations like substations?